Hey everyone, it's Miss Bell here again from the Science Lab, and today we're going to be talking about not only one but two types of energy. Can you guess what they are? Let me give you a hint. And ha. Yes, it is sound and light energy.
So when we talk about sound energy, basically that's just a type of energy that we can hear with our ears. And when an object vibrates, maybe it hits something or something comes in contact with it, it causes movement in the air around that object. And that creates sound waves, and those sound waves travel through the air to our ears, and that's how we can hear sound. Now, when you talk about volume, that's either how soft or how loud a sound is. And with pitch, that either means how low or how high a sound sounds. And when sound energy happens, all those vibrations moving through the air, they can either go really slow, and that'll be a low pitch, or they can go really fast, really fast, really fast, and it'll be a high sounding pitch.
Here I have all sorts of different bottles, some made out of glass, some made out of plastic, some empty, some filled with water, and I want to play around with the sounds and the pitches and the volumes that I can make from these musical instruments. Let's see. And you can even make a musical instrument like a trombone if you get a bottle and fill it with water and place a straw in, and you can move the straw up and down in the water and hear the different sounds. So as my straw moves further down into the water, that pitch is really, really high and squeaky, and as I move it up and blow into the straw, it gets lower and lower in pitch. Okay, right here I have a musical instrument that I tried to make here in the science lab, and all you really need is some sort of sturdy box, a really big, stretchy but strong rubber band, and then something like test tubes or maybe thick markers to use. So with this, we are going to keep this one on the right still, and this one on the left sliding away from the other tube and close to the other tube. And what we're going to pay attention to is how close the two tubes are or how far away the tubes are. And we're going to look at the length of the rubber band right here between the tubes. So here is a long length, here is a kind of medium length, and here is a short length. And with the lengths, that is going to help us hear and determine what kind of pitch it's going to have. So if it's really far and the length is long, it's going to have a low pitch. Can you say that? Low pitch. And then, if they get closer, it's going to have a high pitch. Can you say that? High pitch. And you can adjust the distance from each other. So long, medium, close together. And you can play around with the different pitches and the different sounds that you hear. And here I have two little containers with cut up balloons stretched over the top and secured with the rubber band, almost to where they replicate drums in a sense. And on top of the drums, I placed some items that are considered to be kind of lightweight, like little straw pieces, little grains of rice, some sand, and even some pom-poms. And we're going to take a metal can and a metal spoon, and we're going to tap, 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 tap on the can with the metal spoon all around our little drums. And we're going to see what happens, if anything. What do you think? If I bang on my can close to my drums with all these lightweight objects, are we going to see something happen in front of our eyes? Or will it depend on how close I am to the object versus how far away? What about the position of my can? Does that make a difference? Does it need to be with the hole, facing my drum? Could it be facing away from my drum or facing this way? What about on top versus to the side, the front or the back at an angle? Doesn't matter. That's what's so fun about science. You get to have fun and explore. But I'm going to bang away and we're going to see if anything happens to our drums. And if it does, then why? Why does that happen? Let's find out. And here I have another setup of bottles filled with different colored liquids. And each bottle has a different amount of liquid inside. So this bottle has more of a liquid volume inside versus this bottle. And this bottle has more liquid inside than this bottle. And with the amount of water in each bottle, it's going to affect how that bottle will sound as far as pitch goes. Will the sound be high and squeaky, or will it be low type of sound? And the more water that is in the bottle, that's going to be a high pitch, so squeaky, high, high, high. And if there's little water or even no water, so the less amount of water, is going to be a low sound pitch. So here's our low pitch sounds. And then as I go this way, it gets higher pitched. Here we go. High, low. Let me try blowing in them, see if that makes a difference in sound. You can even play this type of musical instrument and make up songs. Can you name this tune? Here we go. Okay, so for this little demonstration, I'm going to use a tuning fork and a metal spoon. And then back here I have a stand that has a little styrofoam sphere taped to a string that is attached to the very top. And that will allow my little ball to swing freely. But I'm not going to touch the ball myself. Instead, I'm going to let science be the one to move the ball. So what I'm going to do is just tap my tuning fork with my metal spoon, and I'm just going to barely touch the tuning fork to the ball, and we're going to see what happens. So basically, after I hit the tuning fork, there's going to be vibrations, sound vibrations, moving through the air. And as they move through the air, and my tuning fork comes into contact with the ball, those vibrations with that slight touching, it's going to move the ball. And we're going to be able to see how those vibrations can be visible at times. Because if I just do this, we can't see anything. Of course we can hear something and it sounds lovely, but we can't see those vibrations. But you can definitely see it with this demonstration, because I'm not over here banging on the ball. I'm just barely putting my tuning fork up against the sphere. Okay, so I have my tuning forks right here. I have one in my hands, and I'm going to just hit the tuning fork so we can hear what it sounds like before I ever put it in the water. And now I'm going to hit it and then quickly put it into the water, and we should be able to see those vibrations moving the water and making ripples. Here we go. One last experiment I want to talk about with sound energy is these cups right here. You might just think, Ms. Bell, what are we looking at? Cups with some string and these purple things floating underneath them? Well, they have a purpose. And with this little experiment, I'm going to take just regular string and a sponge. And I'm going to pull or drag my sponge across my string. And I want you to see or hear if there's a sound. Let me do it again. I mean, we can hear the scratchy sponge kind of pulling against the yarn or string, and yeah, it's like a slight sound. Let's take that one step further. Do you think or predict that anything would happen if we add a liquid to our sponge? I have some water. I'm going to get my sponge wet, and I'm going to squeeze out all of that extra water, and we're going to do the same thing. And I want you to see if, I don't know, there's a difference in sound. Okay, I got my string, I got my wet sponge. You can already see how the sponge looks different after we got it wet. Let's see if it sounds different. Oh, it has like a, hear it again. Oh, what? It sounds squeaky. So by just simply adding water to our sponge, we were able to see, or hear, I should say, that sound difference. Now, what if we do the same thing, like what I have over here, with a cup instead? All of my sponges are wet. Let's see if there's a sound difference. Come on. Did you hear that? Let me try a different cup. Hold on. That's so cool. It sounds like a really old door at a haunted house. Let's try a different one. Let's try this small one. Almost sounds like a chicken. Bak, bak, bak. Let me try this red Solo cup. Almost sounds like a frog. Ribbit, 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 or a toad. Croak, croak. Last one. Let's see what this one brings. Sounds like a rocking chair. Just all these croaky, amplified sounds. And that's because the wet sponge rubbing against the string like this, it causes what we call friction. And that friction moves the air all around it, giving those vibrations throughout the air, and it travels up the string and in the cup, and then this almost acts like a speaker. It amplifies that sound. It makes it so much louder than when I just had my regular string and I was pulling my wet sponge across it. We could hear it barely here, but we could hear it so much louder over here. Isn't science so fun? Yeah!
Hey everyone, it's Miss Bell here again from the Science Lab, and today we're going to be talking about another type of energy, light energy, which is a type of energy that we can see with our eyes. Now, the light energy that we get from the sun will obviously help plants and flowers and food and trees grow, which we need to survive. And light can be measured by how bright it is or how dim it is. So does it produce a lot of light or a little bit of light? And there are even different types of light, such as natural or man-made. Natural just means that it's found in nature. No one or no person makes it, such as the sun or stars or lightning or a firefly. And man-made light refers to objects that produce light, but either a person had to make that object or a machine had to make it, such as a cell phone, a candle, those cool shoes that light up when you walk on them, or even a strand of lights that you see during the holidays that you have to plug into a wall.
So when we're talking about light energy, we know that light travels in a straight line, but we can't ever really see those straight lines. We can see where the light is coming from, whether it's the sun or a flashlight or a candle, but we can't see all those straight lines on even how they get reflected or even refracted. However, with this short demonstration, I'm going to show you a way that we can see those straight lines of light. I'm going to use a laser pointer and a spray bottle of hairspray. I am going to turn down the light, so it's going to get a little dark, but I need you to be able to see the laser pointer hitting the wall. Here we go. Okay. So here's my laser pointer. When I turn it on, you're able to see that beam of red light hit the wall, but you can't see the line of light. I can put my hand in the way like this, so I'm blocking the red light from hitting the wall. But if I take my can of spray like so and I spray it, we're going to be able to see that beam of light that's hitting the wall. Here we go. And with this short demonstration, you're able to see that straight line of light going from my laser pointer all the way to the wall.
And with this next activity, I'm just using a bunch of CDs clipped together with clothespins, and I'm lining them up in a straight line. And at the very end of my line, I have almost like a target. And my goal with this activity is to shine my light through all of those holes in the middle of the CDs to hit the target. And the way that I'm going to do that is because I know that light travels in a straight line. But as I move my flashlight from side to side, the CDs block the light, and I'm not able to see my light hit the target anymore. I can also use a candle as my source of light energy, and when I put my candle in the very back of my line of CDs, I can see that flame through all the center holes. But when I move my candle light from side to side, again, we're not able to see that light energy because the CDs are blocking those lines of light, and it's not visible to us from this perspective.
So for this activity, we get to look at objects with different levels of brightness or darkness. And all you're going to need for this activity is some sort of box that has a hole cut in the top where you're going to be looking into, and then a hole cut into the side where you're going to take some sort of light source, in this case a flashlight, and you're going to be shining the light on the side of the box. And then you get to peep into the top of the box and try to see, do I know what this object is? Can I take clues from what I can see from the light and make a decision on my guess of what that object is? And you can play around with how dark or how dim or how bright the light is. So for instance, right here, there's no light shining in here, so it's going to be pretty dark when you look into the box. But if you put the light to the side of the box just like this, that's going to be one level of brightness. What if you open the box and you just have the lights from up above in the science lab? And then what if you add even more light? All different levels of light source or light energy being shined upon those objects to help you figure out how does an object look different with different levels of light.
So here I have the first object in the box, and it's very dark because there's no light coming from the side. Now I'm shining the flashlight through the small hole on the side, and you can kind of see because there's a little bit of light. Can you take a guess at what it is? What do you think? Now I open the door and we're able to see just a little bit from the light of the science room, and then I added more light from the flashlight. Do you know what it is now? Well, if you guessed keys, you're correct. Yay! And here I have my second object. Again, there's no light, but here I flashed or shined my flashlight in the side of the box, and you're able to see the little bit of light coming through. Now I opened the box and we're able to see with the science lab lights from above, and then I added the flashlight. Can you guess what it is? What do you think? Well, if you guessed a Lego piece, you were correct. And here is the third object in the dark box with no light, but here's my flashlight shining through, and we're able to see just a little bit of light. Can you take a guess at what it might be? Well, I opened the box and there's some light coming from the ceiling lights, and here is my flashlight. So more and more light coming through. What do you think it is? Well, if you said an eraser or half an eraser, you are correct. Ding, 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 ding. So here's my hand just wiggling around in front of a wall, and you can see the dark area on the wall, and we call that a shadow. And basically a shadow is just a dark shape made when something blocks light from a light source. It could be from the sun, from fire, from a flashlight. And since light travels in a straight line, it stops when it's blocked by something, and that's how shadows are created. When we see light and light hits different objects, those objects might appear differently with the amount of light that can maybe go through those objects. And this is a little advanced, but light might be considered transparent, translucent, or opaque. And when an object is considered transparent, that means that all the light passes through that object. So if you're flashing, if you're shining a flashlight at that object, like saran wrap or clear tape, you're going to see all that light shining through. But if something is considered translucent, that only means that some of the light is going to pass through that object, like wax paper. You're only going to see a little bit of the light. And if something is considered opaque, that means that no light passes through that object, such as foil. If I take a flashlight and shine it at foil, at the back side of the foil, I'm not going to be able to see any light that's passing or trying to pass through that piece of foil. And here I am just looking at objects and seeing what they look like when I'm shining the same light on them. So I'm trying to look at their shadows that they cast on the wall behind them, and I'm observing, what do they look like? What do their shadows look like? Can I see through the object? Can I see through the shadow? Are the shadows dark? Are they light? What do you think? When it comes to light energy, we know that people are able to see objects because of two reasons. It's because that object either gives off light, like the sun or stars or a sparkler, or because that object reflects light, meaning all the light kind of bounces off that object. So people are able to see the sun because it gives off its own light, but people are able to see the moon because it reflects the light from the sun. Light energy can be so fun to learn about and to explore and observe. Take for instance this mirror right here. The mirror is opaque, meaning that the light is not going to go through the mirror. but the mirror reflects all of the light that hits it. So I hope you guys enjoyed this video, and I'll see you guys next time. Bye.